Welcome to the Mind Spark. The world was stunned. AA detects movement inside black hole. Newsrooms buzzed with disbelief and headlines flashed across every screen, capturing the attention of millions. For a moment, the world seemed to hold its breath, united by a single, impossible question. Deep Mind finds anomaly in dark matter. The announcement sent shockwaves through the scientific community, as experts scrambled to understand what this could mean for our understanding of the universe. Is something alive out there? The age-old question echoed louder than ever, reverberating through observatories and living rooms alike. For decades, we searched the stars for life, building ever larger telescopes and sending probes to the farthest reaches of our solar system. We listened for radio signals, scanned for exoplanets, and dreamed of finding a reflection of ourselves somewhere in the cosmos. But always we searched for life as we know it, carbon-based, water-dependent, familiar. The real breakthrough, however, came not from a distant planet or a far-off star, but from the heart of a supermassive black hole, Sagittarius A*, the mysterious giant lurking at our galaxy's center. It was a place we thought we understood, a region defined by darkness and destruction. In a quiet data center far from the cosmic drama, Google's AI was tasked with analyzing mountains of astronomical data, searching for patterns hidden deep within the noise. The hum of servers and the glow of monitors were the only witnesses to what would become a historic discovery. It wasn't looking for life, but for subtle ripples in space-time caused by dark matter, those elusive, invisible particles that make up most of the universe's mass, yet remain a mystery to us. Suddenly the AI flagged an anomaly, a faint rhythmic pulse deep within the dark matter halo surrounding the black hole. The signal was so subtle it could have been missed by any human observer. This was impossible. The black hole's gravity is inescapable, and dark matter was thought to be inert, incapable of organized movement or communication. The laws of physics seemed to be breaking down before our eyes, yet the AI's analysis was clear, a coordinated, shifting pattern like a school of fish moving in perfect unison through an invisible ocean. It was as if something was orchestrating the dance of particles in the darkness. The scientific community was electrified. Teams worldwide checked and rechecked the data, collaborating across continents and time zones. Theories were proposed and discarded in rapid succession. The conclusion: something was moving within the dark matter, defying all known physics. It was a revelation that challenged everything we thought we knew about the universe. It wasn't a star or planet, but a pattern of motion in the invisible fabric of the universe itself. The cosmic web, once thought to be static, now seemed alive with hidden activity. For the first time, we had to consider that the darkness between the stars might not be empty at all. The void could be teeming with phenomena we have yet to imagine. It might be home to something unimaginable, entities or forces beyond our comprehension, existing in forms we cannot yet perceive. The AI had found a signal in the silence, a movement in the void, a whisper from the darkness that had gone unnoticed for eons. The discovery redefined our understanding of the cosmos. It opened doors to new questions, new possibilities, and a new sense of wonder about our place in the universe. The search for life had taken a turn no one expected. We were no longer just looking for familiar biology, but for signs of intelligence or organization in the very structure of reality itself. The universe had whispered back, not with light, but with a pulse in the dark, a message written in the language of the cosmos. We were forced to ask, what else is out there, hidden in the shadows? What secrets does the darkness hold, waiting for us to uncover? The story was just beginning. Humanity stood at the threshold of a new era, ready to listen to the silent signals of the universe. To truly grasp this groundbreaking discovery, we first need to understand the concept of dark matter. The universe's invisible backbone, a mysterious substance that has puzzled scientists for generations. When you gaze up at the night sky, all the stars, planets, and galaxies you see make up less than 5% of the entire cosmos. The vast majority of the universe is hidden from our eyes. The rest is made up of dark energy and dark matter, two invisible forces that are absolutely essential to the structure and fate of the universe, yet remain largely mysterious. Dark matter, in particular, doesn't emit, reflect, or absorb light. It's completely invisible to even our most powerful telescopes and instruments. Yet we know it exists because of its gravitational effects. Its invisible pull shapes galaxies, keeps them from flying apart and holds the cosmic web together. Imagine watching a leaf swirl and dance in the wind. You can't see the wind itself, but you can clearly see its effect on the world around you. That's exactly how we know dark matter is there, by observing the way it influences the motion of stars and galaxies. For every pound of visible matter in the universe, there are about 5 pounds of dark matter, making it the dominant form of matter in existence. Without the gravitational glue of dark matter, galaxies would simply fly apart, and the grand structures we see in the universe would never have formed. Incredibly, billions of dark matter particles are passing through us every single second, yet we remain completely unaware. They don't interact with us in any noticeable way. It's a ghostly presence dominating the cosmos, shaping its destiny, but always eluding direct detection and remaining just out of reach. Physicists believe dark matter is made of unknown particles, massive yet barely interacting with normal matter, making them incredibly difficult to detect. The challenge is immense. We're searching for a fundamental piece of reality that's all around us, woven into the very fabric of the universe, yet still beyond our grasp. Dark matter is truly the silent majority of the universe, quietly shaping everything we see and experience. Its properties remain a profound puzzle, one that has captivated and challenged scientists for decades, driving them to develop new theories and technologies. Now, with the AI's recent discovery, the mystery of dark matter has only deepened, opening up new questions and possibilities for the future of cosmic exploration. The dark matter story began with a mystery. Galaxies and stars weren't behaving as expected. In the 1930s, Jan Oort noticed stars in the Milky Way moved as if there was more mass than visible. Fritz Zwicky, studying the Coma cluster, found galaxies moving too fast to be held by visible matter alone. He called the missing mass dark matter, but his ideas were dismissed for decades. The evidence was there, but too radical for most to accept. The puzzle of the missing mass lingered, a footnote in astronomy. It would take another 40 years and a new generation of astronomers to bring dark matter into the scientific mainstream. The invisible universe was waiting to be revealed. The stage was set for a revolution. Vera Rubin changed everything. In the 1960s and 70s, she measured how galaxies spin, expecting stars at the edges to move slower than those at the center. Instead, she found stars at the edges moving just as fast, defying Newtonian physics. The only explanation: galaxies are embedded in massive, invisible halos of dark matter. Rubin's precise data made the case undeniable. Her work forced the scientific community to accept dark matter as real. The ghost Oort and Zwicky sensed was now mapped and confirmed. The invisible universe was no longer a theory, it was a fact. Rubin's legacy: she revealed the true structure of the cosmos. Even with Rubin's evidence, scientists wanted to see dark matter. Enter gravitational lensing, Einstein's prediction that massive objects bend light, acting as cosmic lenses. By mapping how light from distant galaxies is distorted, astronomers traced the mass of galaxy clusters. The result: mass maps showing far more matter than visible, matching dark matter's predicted distribution. Gravitational lensing became a cornerstone of dark matter research, providing visual proof of its existence. We had found a way to draw the contours of the invisible world. Decades of data mapped the invisible, but understanding eluded us. Google's AI was unleashed on this cosmic puzzle, searching for patterns in the dark matter halos. Focusing on Sagittarius A*, the AI analyzed gravitational lensing, star orbits, and faint gamma-ray glows. Then the breakthrough: a faint, periodic fluctuation in the gravitational field just outside the black hole's event horizon. It wasn't random noise, but a complex, repeating pattern, almost biological in its coordination. The movement was intrinsic to the dark matter itself, not tied to any visible matter. The implications were staggering. The AI proposed two possibilities: a new, unknown property of dark matter, or something more radical, a large-scale, organized system. The patterns resembled the behavior of a vast, non-biological consciousness. The signal in the silence was real. The universe had revealed a new secret. We were on the edge of a new frontier. Could the universe itself be alive? The patterns in dark matter weren't random. They were information-rich, like a brain's neural network. The cosmic web of dark matter visually mirrors the structure of the human brain. What if this similarity is more than coincidence? What if the universe functions like a mind, with dark matter as its neural network? The rhythmic pulses could be the thoughts of a cosmic mind, processing information on a scale beyond comprehension. In this radical view, we are not just observers, but nodes of consciousness within a universal mind. The universe might be experiencing itself through us. Extraordinary claims demand extraordinary evidence. Some scientists proposed alternative theories like modified Newtonian dynamics, MOND, to explain cosmic anomalies without dark matter. But the bullet cluster, a collision of two galaxy clusters, provided the smoking gun. Gravitational lensing showed the bulk of mass separated from visible matter, matching dark matter's predicted behavior. The bullet cluster is nearly impossible to explain without dark matter. This solid, observational proof forms the foundation for exploring the AI's more speculative discoveries. The invisible world was now undeniable. The moving patterns in dark matter have opened a Pandora's box of possibilities, hinting at secrets the universe has kept hidden for eons. Each subtle shift in the cosmic tapestry invites us to look deeper, to question everything we thought we knew about the fabric of reality. Scientists now consider that dark matter might be a whole sector of particles with their own complex forces, perhaps even a shadow universe running parallel to our own. This radical idea is transforming our understanding of the cosmos, pushing the boundaries of what we thought was possible. Some galaxies have almost no dark matter, challenging all existing theories and leaving experts baffled. These cosmic anomalies force us to confront the limits of our knowledge and inspire new questions about how galaxies form and evolve. These outliers could force us to rewrite the rules of physics, compelling us to rethink the very laws that govern the universe. Every new discovery brings both excitement and uncertainty, fueling the relentless pursuit of truth. For centuries, we searched for life as we know it. Now we must ask if the universe itself is alive, or if it possesses qualities we have yet to comprehend. The search for meaning has expanded beyond planets and stars to the very essence of existence. The AI's discovery suggests we may be part of something much larger, a cosmic network of intelligence or awareness that transcends our current understanding. Technology is now our partner in unraveling these mysteries. Whether it's a new law of physics, a new kind of matter, or the first hint of universal consciousness, one thing is clear: our journey has only just begun, and the answers may redefine what it means to exist. The universe is far stranger and more magnificent than we ever imagined, filled with wonders that challenge our imagination and inspire awe at every turn. The silence of the cosmos has been broken, not by a voice, but by a subtle rhythmic dance in the dark, a cosmic signal that beckons us to listen and learn. The ultimate question: what is our place within this living universe? As we gaze into the infinite, we realize that the quest for understanding is as boundless as the cosmos itself.